Often asked to people who are either beginners in data science or people with less number of years in data science. One of the commonly asked question is what are the the common data quality issues faced in modeling. When you build models, you face a number of data quality issues, and before you start building model, you need to handle these issues or overcome this issue, because otherwise you will not have a good model. The issues you could face are, there could be issues with data type. Okay, like values in column should be of same data type, right? If you have a column, let's say salary, right? Salary, it has to be a number, it cannot have a text value, right? Similar issues can also be found in other columns. So ensure that the data quality, the data type of a particular column has to be same throughout, otherwise it's a data quality issue and you need to correct that first. Range constraints, like some data always fall in a particular range. For instance, probability. Now, probability always has a minimum value of 0 and maximum value of 1. It cannot be a negative number and it cannot go beyond 1. It has to be between 0 and 1. So that's a range constraint. That is always there for a number of different variables, and ensure that you check that before you go ahead with modeling. Mandatory constraint. In certain data, in certain variables, they cannot have zeros or empty values. So ensure that it doesn't have a particular value. It could be 0, it could be a certain number, or it could be the case that the value, the column cannot be empty. Okay, so that is another important check. Unique constraint. A field must be unique across data sets. Like if you're having several data sets across different projects, your variable should have unique definitions or unique values across all the data set. It cannot have multiple values, otherwise that's a erroneous data, and ensure that it gets captured before you build models. Value constraint. So for instance, gender can only have male and female. It cannot have 4 or 5 values, right? So that's one important check ensure to do. Constraint on pattern. Okay, for instance, if you are having a data on phone numbers, then sometimes it has to be it has to be with the ISD code, and the ISD code is between bracket. Ensure that it's proper for all the data points. Spelling error. Sometimes your data could have a spelling error, that could cause issues. Missing values and the reason behind it. This is very important data quality issues to be checked, and ensure that you find a reason behind why is the data missing in a particular column. Outlier detection. Outliers are a big problem in modeling. Ensure that you detect outliers and remediate before you start building models. Cross-field validation. For instance, the date of somebody is joining the firm cannot be before the date of his birth, right? The simple thing. Or date of a patient discharge from hospital cannot be before date of his admission to the hospital. So these are very small checks, but sometimes because of erroneous data, because of data received from wrong resources, you might find such issues, and ensure that all these issues have been taken care of before you start building models. Another important question often asked is, what is the life cycle of a data science or analytics projects? It's a simple questions, but even sometimes experienced data science people make mistakes while answering questions. The reason is because the steps involved in data science or analytics projects differs across domains, and it also differs depending on which companies you're working for. But there are some important steps that are common between data science projects across domains. First one is data acquisitions. So the first thing is to get data from internal and external sources and collate them, and ensure that you have a proper data in place before you can go ahead with doing anything other than your anything more than data acquisition and um, Data preparation. So the next one is you clean the data to make it look very suitable for modeling. So that's the second step. And we also looked at what are the data cleaning steps or data quality issues that you might face. So all that has to be done in the step. Modeling. Then you go ahead with building models using statistical algorithm or machine learning algorithm. And you validate your model and select the best model. Then you evaluate and interpret the models. Models are evaluated and tweaked so as to improve performance. And then you deploy models to ensure that your model is in production and working fine. And once the model is there in production, you monitor on a regular basis to ensure that model is performing well. Just in case you find that model is not working fine during the monitoring process, then you flag that and then you rebuild the model or re-estimate the model. So these are the common steps. Again, it all depends on which project you are working in, and there could be several changes to these steps. How do you control bias in a model? Well, you can control bias in the model by doing the following things. Ensure that the sample that you are using to build model is representative. And what do we mean by representative? That means the distribution of different variables should be same across samples. Okay, or population and sample. You have a large population and you take a sample from that. This is population and this is sample. Okay, and you have, let's say, two variables, v1 and v2, and you have taken sample v1 dash and v2 dash. So if the mean, the standard deviation, okay, and then maybe the distribution, the sample distribution, so all that has to be similar in also in this sample, and that only then it is a representative, otherwise it is not. So the sample statistics should more or less match, if not exactly same, at least to be very close to each other. That's representative. There are also other statistical tests to prove that your sample is representative, but even without statistical tests um, you can test whether your sample is representative or not. Ensure that you have a large sample to build model. That always helps. Include all important predictors. Otherwise, you will be not having a very good model. Ensure that as many predictors are tried out at least. Not all predictors are going to be in the final model, but ensure that all the predictors have been tried in the model. Avoid using highly correlated variable, otherwise that could create issues or that could bring down the performance of the model on several occasions, and also create issues while interpreting the models. So that's should be kept in mind. Randomize the sample selection. When you take a sample, ensure that it's a random sample. There should not be any bias in that. So the sample selection should be simple random or stratified random sampling, and such method has to be used. Explain what is a lift of a model. So lift is an indicator to measure how effective the model. And often in marketing analytics, in credit risk analytics, lift is a very commonly used matrix used to evaluate model performance in the productions. And lift is given by target response divided by the average response. So for instance, let's say that the model has been built for a click-through rate of ads. So the CTR is 5% without the model and CTR is 15% after the model has been in use. Then the lift would be just 15 by 5, which is 3. Although it's simple to calculate, but it normally in productions or when we find it out in real uses, we do it for different quantiles and use that as a measure for a marketing strategy or risk strategy. So how do we do that? Let's say, for instance, we calculate this lift using the same formula for, let's say, 10 quartiles. Okay. Um so so that would be, for every percentile, sorry, for every decile we would have a lift, right? So decile 1 to up to 10, and we'll have a lift, corresponding lift, right? So if you have that in place, we can say that a certain percent of click-through rate can be achieved by just looking at the first two quartiles, first two deciles, and that would be very useful because given the cost involved in marketing programs or handling risk, it is always good to look at only the top quartiles. And what is the click-through rate in the top deciles is very important from a strategy point of view. So for instance, we can say that 60% of this CTR or click-through rate is happening in just the 20% of the ads or the top two deciles which have been scored by the models. So that's exactly is left used for. Explain identification handling of outliers. Well, how do you identify outliers? Firstly, through visualization, you plot the data and you will find many data points, very different from the other data points. Only a section of data points are, at a very distance from the usual data points or most other data points. There could be outliers. Other methods could be use the 3 sigma rule. Like anything that lies beyond 3 standard deviation from the mean can be treated as a outlier. Although this is not a rule of thumb, many other consideration has to be made whether that actually affects your model greatly or not. Is that an important variable? Is that an measurement issue, or is a proper data? So all that has to be taken into consideration. And in case you have only small number of data points lying in that area, then there's hardly an issue in that. Other methods could be using box plot, QQ plots, and then there are statistical measures like measuring the Cook's distance and taking a threshold, and anything that is beyond the threshold, just remove them. So that's one way of identifying outliers. How to handle them? So you can remove them from the data if there is hardly any effect on the model. Um, Sometimes if you transform the variable, you take logarithmic transformation or any other type of transformation, then also outliers effect are reduced, and then you have a better data in place. In case you cannot remove them, then you can use robust statistical estimation methods. Like robust regression is one method which helps getting rid of outliers. All right, you can also use weight of evidence, often used in credit risk industry, which helps you to get rid of outliers. So weight of evidence transformation of variables completely get rid of helps in getting rid of outliers. Explain what is curse of dimensionality in modeling point of view. So this is often cited when data is of high dimension. That means there are a lot of variables, and that actually creates problems. Although it helps in some sense, but it also creates issues. It reduces the number of options that you have in terms of choosing algorithms. Not all algorithms can be very effective in high dimension. In fact, some of the algorithm cannot be estimated. So if you're using ordinary least square algorithm, your number of independent variable has to be less than the total number of data points. Okay, otherwise OLS cannot be estimated. In fact, many other algorithms cannot be estimated through this. So data availability is an issue in such a case, because if you do not have enough data, many algorithm will not just work. So that's the issue with high dimension thing. And then significance test is an issue. Although for prediction purpose, you can build some of the algorithms, but the actual use of model is not just for prediction. It's also to know the inference or the relations between variables, and for that you need significance test, statistical significance tests, and that won't very feasible in many cases. And many algorithms are not suitable, and some algorithms are highly suitable for such cases. So that's pretty much what's known as curse of dimensionality. How to test regression classification, whether they are working fine or not. For regressions, the standard measures or matrix when we look at are the follows: R square. It explains how much variation the dependent variable is explained by the set of independent variables. Root mean square error. And we also look at the Akaike information criteria and squash Bayesian criteria. So these are commonly used statistics used to select the best model out of several regression models. For classification, we used C statistic, accuracy, misclassification error, again AIC and BIC as well. Explain the uses of resampling methods. So what are the uses of resampling methods? And you might have come across many algorithms which uses resampling. So resampling is about repeatedly drawing samples from training set and refitting the model of interest on each sample in order to obtain the additional information about the fitted model. Now you have a model in place, and then you fit that model with several data sets drawn from this training data set, and then you see how your model is varying, and you get a lot of insight about your model when you take different subsample from your training sample. and sometimes it also helps you bettering your model or improving your model. So some of the common uses are cross validation to ensure that the model is working fine, not just in training set, also in new data on test set. So cross validation is one area where you take the number of cross validation like k-fold cross validations, often use resampling techniques where k number of samples have been taken from your training set to evaluate the model, and then you average it out, right? Anyone familiar with cross validation knows that resampling is very much used. Bootstrapping is used when you take a sample but with replacement, right? And bootstrapping is used in ensemble modeling, right? In bagging, boosting, and random forest, and many other variations of bagging, boosting, right? Like gradient boosting or XG boosting, extension boosting. Many such boosting algorithm uses bootstrapping. So thank you so much, and please subscribe to our channel.